1. The silence after the discovery. The first sign that something had gone wrong was not an error, but a pause. In controlled scientific environments, silence is rare. Machines generate constant feedback, systems log every fluctuation, and researchers speak continuously, questioning, validating, correcting. Progress is noisy by nature, but after the final result appeared, the noise faded. Not abruptly, but gradually, as if the room itself sensed that movement should stop. The data had arrived exactly as predicted. That alone was unsettling. There were no anomalies to dismiss, no faulty readings to blame, no statistical irregularities to debate. The numbers aligned too cleanly with the models. Replication produced the same outcome. Independent systems confirmed it. From a purely technical standpoint, the discovery was flawless. Yet no one reached for celebration. No one smiled. What followed was not excitement, but restraint. Scientific breakthroughs are usually moments of release. Years of uncertainty collapse into clarity. Questions turn into answers. Careers are made in seconds. But this moment did the opposite. It compressed the room inward. Researchers leaned back from their screens. Some stood without speaking. Others stared longer than necessary, as if waiting for the result to change on its own. It did not. There was an unspoken recognition that this was not simply a new piece of knowledge. It was a transition from observation to consequence, from understanding how something works to realizing that it could now be directed, modified, or scaled. No one announced this realization. It arrived instinctively, before language had time to form around it. In science, unease is not considered evidence. Feelings are not data. But here, unease preceded analysis, and that reversal mattered. The discomfort was not emotional in the ordinary sense, it was structural. A quiet awareness that the discovery had collapsed a boundary that previously existed only as an assumption. A boundary that had never been written into law or policy, but had been quietly trusted to remain intact. For decades, scientific progress had advanced through layers of abstraction. Models, simulations, probabilities, safe distances between theory and reality. This discovery eliminated that distance. It demonstrated that what had been treated as theoretical was now operational, not hypothetical, not experimental, functional. The silence that followed was not fear of what the discovery was. It was recognition of what it allowed. Because capability changes the nature of responsibility. Once something can be done, the question is no longer whether it should be understood, but whether it should be used. And science, for all its precision, has never been designed to answer that question quickly. Researchers began rerunning procedures, not because they doubted the outcome, but because repetition created time. Time to think, time to delay the next step. In the language of science, this looked like caution. In reality, it was hesitation, a collective instinct to slow the forward motion of progress without fully admitting why. What made the moment especially unsettling was its ordinariness. There was no dramatic failure, no visible danger, no immediate harm. The discovery did not announce itself as catastrophic. It simply existed quiet, correct, and irreversible. The kind of result that would eventually be described as inevitable, but only after it had already happened. This is how most lines are crossed. Not through defiance, but through momentum. Each individual step justified, each experiment ethical in isolation, each decision rational within its context. No single action feels like a violation. The realization only emerges afterward, when the cumulative effect becomes visible all at once. In the silence, scientists were not asking what had gone wrong. They were asking, silently, whether something fundamental had shifted without anyone noticing. Whether the framework that once separated discovery from intervention had dissolved. Whether the role of science itself had quietly changed. There were no protocols for this moment, no checklist for what to do when success feels like a warning. Ethics committees exist, but they operate on known risks. This was different. The risk was not yet defined. The consequence was not yet measurable. Only the intuition remained that whatever came next would not be undone by simply shutting the system down. Eventually, someone spoke. Then another. Conversations resumed, carefully, choosing words with unusual precision. Not because the science was unclear, but because the implications were. The silence broke, but it did not disappear. It lingered beneath every discussion, shaping what was said and what was deliberately left unsaid. Outside the room, nothing had changed. The world continued as normal, unaware that a threshold had been crossed quietly, without ceremony. No announcement was made, no alarm sounded. And yet, in that pause between discovery and disclosure, science encountered a question it could not immediately answer. Not can this be done, but what does it mean that it can? 2. the line humanity always believed existed. Long before the silence after the discovery, science had been guided by an invisible assumption that there were limits, not limits imposed by law or technology, but boundaries woven into human understanding itself. Lines that were rarely written down, yet widely trusted. They existed somewhere between ethics, nature, and belief, and for generations, they offered a sense of reassurance, not certainty, but comfort. From the earliest attempts to understand the universe, humans separated what could be known from what should remain untouched. Ancient philosophers spoke of natural order. Early scientists believed reality followed rules that could be observed but not rewritten. Even as knowledge expanded, there was an underlying confidence that some domains were fundamentally off-limits, not because of fear, but because of presumed impossibility. This belief shaped how progress was framed. Discovery was acceptable. Measurement was encouraged, explanation was celebrated, but intervention carried a different weight. To understand lightning was admirable, to control it felt audacious, to map the human body was noble, to alter its fundamental processes raised questions that extended beyond science itself. These distinctions were not always explicit, but they were deeply ingrained. As centuries passed, these lines evolved, but they never disappeared. Each era had its version: nature versus machine, life versus mechanism, intelligence versus calculation, randomness versus design. These divisions acted as psychological guardrails. They reassured societies that no matter how far science advanced, it would eventually encounter a boundary it could not cross. Importantly, these boundaries were rarely tested directly. They functioned more like assumptions than rules. Most scientists did not wake each day thinking about limits. The limits were simply there, embedded in what seemed reasonable, ethical, or possible. They allowed progress to feel safe because it appeared contained. The sense of containment was reinforced by history. Every major breakthrough initially appeared to approach a boundary only to stop, short of rewriting the underlying structure of reality. The atom could be split, but not endlessly controlled. Life could be studied, but not designed from scratch. Intelligence could be analyzed, but not replicated. At least, that was the belief. These assumptions shaped education, funding, and institutional ethics. Research questions were framed within what was thought to be achievable. Risks were evaluated against known outcomes. Oversight existed precisely because there was confidence that science operated within a stable framework of limits. The idea that a line might vanish entirely was rarely considered. What made these boundaries powerful was not that they were proven, but that they were shared. A collective understanding that certain transformations belonged to philosophy, theology, or speculation, not laboratories. This separation gave science legitimacy. It allowed societies to trust progress without constantly renegotiating moral foundations. But over time, the nature of scientific inquiry changed. Advances no longer came in isolated leaps but through accumulation. Each step was modest, each experiment reasonable, each application justified by precedent. The lines were not challenged head-on, they were approached indirectly, from angles that did not appear threatening. As tools became more precise and systems more complex, the distinction between observing and influencing began to blur. The questions scientists asked subtly shifted. Not just how does this work, but can this be adjusted? Not just what is, but what could be optimized. These shifts were incremental, almost invisible, and they felt like progress rather than transgression. The comfort provided by old boundaries began to rest on habit rather than reality. People believed the lines still existed because they always had, because crossing them had once seemed unthinkable, because science, historically, had moved slower than imagination. What no one fully accounted for was that assumptions are not safeguards. They do not enforce themselves. They rely on the belief that certain things will remain impossible long enough for ethics, policy, and understanding to catch up. When that belief fails, the boundary does not announce its disappearance. It simply stops functioning. By the time scientists began to sense that something fundamental had shifted, the line was no longer clearly visible. It had not been broken in a single moment. It had been eroded quietly, rationally, and without resistance, and what had once provided comfort now offered no guidance at all. This is the context in which the silence after the discovery became meaningful. It was not just about what had been achieved, but about the realization that the old map of limits no longer applied. The boundary humanity believed in had not held, not because anyone intended to cross it, but because no one noticed it fading. And once that realization settles in, a more unsettling question emerges. If the lines we trusted were only assumptions, what else have we been relying on without proof? Progress without permission. Once the belief in fixed boundaries began to weaken, progress did not surge forward dramatically. It accelerated quietly. not through singular breakthroughs or public declarations, but through accumulation small, justified advances layered so precisely that no one step appeared extraordinary. Each decision made sense in isolation. Each development followed logically from the last. And because no single moment felt decisive, no permission was ever sought. Modern science no longer advances through isolated discoveries alone. It moves through networks, distributed teams, shared datasets, automated systems, and iterative refinement. Responsibility, once concentrated in individuals or institutions, became diffuse. Decisions were no longer made in one room by one group, at one time. They were made everywhere, continuously, and often invisibly. This shift altered how accountability functioned. When progress is incremental, it feels manageable. When decisions are spread across disciplines and geographies, no single actor appears to hold the whole picture. Ethical review processes still existed, but they evaluated steps, not trajectories. Each proposal was assessed against current standards, not future consequences. The system was designed to ask whether an action was acceptable, not whether its cumulative effect would be transformative. Technology played a crucial role in this acceleration. Automation reduced the friction between hypothesis and result. Computational models allowed exploration of possibilities that once required decades of physical experimentation. Machine-assisted analysis uncovered patterns humans would not have noticed on their own. Progress did not just speed up, it became self-reinforcing. As tools improved, the scope of what could be tested expanded. Experiments that once seemed impractical or ethically distant became routine, because their immediate impact appeared minimal. A minor adjustment here, a controlled optimization there. Nothing that felt like a line crossing. Just refinement. This is how permission quietly became irrelevant. No global discussion preceded these shifts because there was no obvious moment to pause. Public awareness lags behind technical capability by design. Most advancements occur far from public view, embedded in specialized language and abstract systems. By the time outcomes reach everyday life, they appear as conveniences, efficiencies, or natural progress. Importantly, this process was not driven by recklessness. It was driven by success. Each advancement validated the approach that produced it. Funding followed results. Institutions rewarded productivity. Researchers were encouraged to push boundaries not because they intended to erase them, but because progress itself became the metric of responsibility. The ethical frameworks surrounding science struggled to adapt because they were reactive by nature. They responded to identifiable risks, known harms, and historical precedents. What they could not easily address were slow, structural shifts, changes that did not produce immediate damage, but altered the landscape of possibility. Over time, the question, should we proceed quietly, transformed into why wouldn't we? When capability exists and no harm is immediately visible, restraint begins to feel irrational. Delaying progress appears less ethical than continuing it, especially when benefits, medical, economic, or informational, can be clearly demonstrated. This is the paradox of modern progress. It advances not through defiance of ethics, but through compliance with them. Every step is justified, every experiment approved, every application aligned with existing norms. Yet the accumulation of these steps leads somewhere no single review process was designed to evaluate. By the time anyone notices the trajectory, the system is already in motion. Dependencies have formed, infrastructure has been built, knowledge has spread. Reversing course becomes not just difficult, but destabilizing. The cost of stopping begins to outweigh the cost of continuing. This is why the moment of realization does not arrive with the breakthrough itself, but afterward, when the implications of cumulative progress finally become visible all at once. Not as a sudden leap, but as a dawning awareness that the destination has already been reached. And in that realization, blame feels misplaced. There is no single decision to undo, no individual to confront, only the recognition that progress, once distributed and automated, no longer waits for permission. It moves forward because the system itself rewards motion. This understanding reframes the silence after the discovery. It was not shock at what had been done, but recognition of how easily it had happened, and how quietly the collective ability to choose had been replaced by the momentum of capability. 4. When observation turned into intervention. For most of its history, science understood itself as a mirror held up to reality. Its role was to observe, measure, and describe what already existed. Even when discoveries were disruptive, they were framed as revelations rather than alterations. Reality was assumed to be fixed. Science merely uncovered its rules. This assumption provided a sense of humility. Nature was complex, but it was not negotiable. The transition away from this posture did not occur in a single moment. There was no announcement that science had moved from observer to participant. Instead, the shift revealed itself through a pattern subtle, gradual, and difficult to isolate. It began when understanding something well enough made the temptation to adjust it seem reasonable. Once mechanisms were mapped, variation no longer felt like interference. It felt like experimentation. At first, these interventions were cautious and limited. Adjustments were framed as corrections rather than redesigns. Models were fine-tuned, processes optimized, variables controlled more precisely. Each action remained grounded in the language of observation, even as it quietly altered outcomes. The distinction between studying a system and shaping it began to blur, not because anyone intended to erase it, but because the tools no longer respected the difference. This change was reinforced by success. When small interventions produced predictable results, confidence grew, control replaced uncertainty. Feedback loops shortened. Science became less about asking what is and more about determining what works. The emphasis shifted from explanation to performance, from understanding causes to achieving outcomes. Crucially, this transformation did not feel radical. It felt efficient. Intervention was justified as a means of reducing error, increasing reliability, or improving precision. In many cases, it produced undeniable benefits. Systems became more stable, predictions more accurate, outcomes more consistent. These improvements reinforce the belief that intervention was simply the logical extension of observation. Over time, however, the scope of intervention expanded. Adjustments moved from surface-level parameters to foundational processes. What had once been treated as background conditions became variables to be manipulated. The question was no longer whether reality should be changed, but whether it could be changed safely. This is where the pattern becomes visible. Across disciplines, the same trajectory emerged. First, measurement, then modeling, then optimization, finally, alteration. Each stage built naturally on the previous one. At no point did it feel like a boundary had been crossed. The transition occurred within the existing logic of progress. The language of science adapted accordingly. Terms like intervention and modulation replaced older distinctions between natural and artificial. These words carried a sense of precision and control, minimizing the perception of risk. They suggested that reality was not being rewritten, only adjusted within acceptable parameters. Yet something fundamental had shifted. Science was no longer confined to interpreting the world as it was. It had begun to participate in shaping the conditions under which the world operates. This participation was not absolute, but it was real, and it carried consequences that extended beyond individual experiments. Importantly, this shift did not provoke immediate ethical resistance, because its effects were rarely visible in isolation. Interventions were localized, controlled, and often reversible, at least in theory. They did not announce themselves as transformative. They accumulated quietly, reinforcing the sense that science remained safely within its traditional role. The realization came later, when patterns across fields began to align, when it became clear that intervention was no longer an exception, but a default, when observation alone began to feel incomplete, even insufficient, when understanding reality without the ability to influence it seemed like an unfinished task. This is the moment that reframes the earlier silence. What unsettled scientists was not that intervention had occurred, but that it now felt unavoidable. The tools in use were no longer designed merely to watch the world. They were designed to engage with it, adjust it, and improve it according to chosen criteria. The shift was quiet but decisive. Science had crossed from description into participation, and once that transition is made, returning to pure observation is no longer possible, not because it is forbidden, but because the knowledge itself changes what observation means. What follows from this realization is not alarm, but responsibility. And responsibility, when paired with accelerating capability, introduces questions that science alone cannot answer. 5. The experiment that couldn't be unseen. Irreversibility in science rarely arrives with destruction. More often, it arrives with clarity. A result so definitive that it cannot be dismissed as error, and so informative that it permanently alters what is considered possible. This was not a single experiment, nor a dramatic breakthrough confined to one field. It was a threshold moment, when multiple lines of inquiry converged and revealed the same unsettling truth. The experiment could not be unseen because it did not merely demonstrate a phenomenon. It demonstrated control. It showed that intervention was not only theoretical or limited, but repeatable, scalable, and transferable. Once that realization took hold, the knowledge itself became irreversible. Even if the systems were shut down, the understanding would remain. In scientific practice, This is a critical distinction. Equipment can be dismantled, projects can be paused, funding can be redirected, but knowledge, once validated and shared, cannot be erased. It propagates through publications, training, and institutional memory. It reshapes how future questions are asked, even when the original experiment is never repeated. What made this threshold particularly significant was that its implications extended beyond the immediate context of discovery. The results suggested that similar methods could be applied elsewhere, that the principles underlying the experiment were not unique but general. This universality transformed a local success into a global consideration. At first, the realization emerged indirectly. Researchers noticed that assumptions they once treated as constraints no longer applied. Variables previously considered fixed began to behave as adjustable parameters. Systems thought to be too complex to direct responded predictably to carefully designed inputs. The shift was subtle but cumulative. As evidence mounted, discussions changed in tone. Not louder but more careful. Conversations that once focused on whether something worked now centered on how far it could be taken. Risk assessments expanded from immediate outcomes to long-term trajectories. The language of possibility began to carry weight. This is where tension enters the story, not through conflict, but through inevitability. Once the experiment demonstrated that a threshold had been crossed, restraint became a choice rather than a default. Continuing was no longer a matter of curiosity alone. It became a question of responsibility. But responsibility without precedent is difficult to define. Importantly, nothing visibly broke when the threshold was crossed. There was no immediate harm, no sudden disruption. In fact, the success of the experiment reinforced the perception that intervention was manageable. The danger, if it could be called that, lay not in what happened next, but in what no longer felt impossible. Scientists began to recognize that they were no longer exploring the edges of understanding, but expanding the interior of capability. The boundaries that once constrained experimentation had shifted inward. What had been exceptional became replicable. What had been speculative became operational. This realization produced a unique kind of tension. Not fear of failure, but awareness of permanence. The understanding that future decisions would be made in the shadow of this knowledge. That even choosing not to act would now be an informed decision, shaped by what had already been revealed. The experiment could not be unseen, because it redefined the starting point of all subsequent inquiry. It altered the baseline. From this moment forward, science would operate with the awareness that certain interventions were not just possible, but proven. The burden of proof had shifted from can this be done to should it be done again. And it is here that the silence from earlier sections gains its full meaning. It was not a reaction to danger, but to permanence. The recognition that something essential had changed, and that there was no clear way to return to the assumptions that once provided comfort. The threshold had been crossed quietly, not by intent, but by accumulation. And once crossed, it did not announce itself as an ending, but as a beginning whose consequences would unfold long after the experiment itself was complete. 6. Ethics after capability. Ethics is often imagined as a guiding force, something that precedes action and shapes what is allowed to happen. In practice, it rarely functions that way. Ethical frameworks tend to emerge in response to capability, not in anticipation of it. History shows a consistent pattern. First, something becomes possible. Only afterward does society begin to ask whether it should exist at all. This pattern is not the result of negligence or malice. It is structural. Ethics depends on context, and context is difficult to imagine without concrete examples. Moral reasoning requires scenarios, consequences, and trade-offs, elements that only become visible once a capability has been demonstrated. Until then, discussions remain abstract, speculative, and easily postponed. In the wake of the irreversible threshold, this gap became impossible to ignore. Scientific capability had advanced to a point where ethical questions could no longer remain theoretical, yet the frameworks designed to address them were rooted in earlier assumptions about pace, scope, and control that no longer applied. Ethics committees, regulatory bodies, and institutional review boards were structured to evaluate discrete actions, not systemic transformations. They assessed risk based on known outcomes, not emergent ones. Their authority depended on precedent, and precedent could not exist for something genuinely new. As a result, ethical evaluation lagged behind technical reality, not because it failed, but because it was not designed for acceleration. This delay created a subtle but important shift in responsibility. When capability advances faster than ethical consensus, decision-making moves upstream into laboratories, design choices, and implementation details. Scientists and engineers find themselves making ethical judgments implicitly through what they choose to pursue, optimize, or scale. These decisions are rarely framed as moral choices, but they are consequential nonetheless. The discomfort arises when those involved recognize that they are operating beyond the guidance of established norms. Without clear boundaries, restraint becomes personal rather than institutional. Different individuals draw different lines, informed by experience, intuition, or professional culture. What one group considers acceptable experimentation, another may view as premature or risky. This fragmentation of ethical judgment is not inherently chaotic, but it is unstable. It produces uneven standards and inconsistent oversight. More importantly, it shifts the burden of moral reasoning onto those least equipped to carry it alone. Individual researchers working within systems that reward progress, efficiency, and innovation. Public engagement with these questions tends to arrive even later. By the time ethical concerns enter broader discourse, capabilities are often already embedded in infrastructure, commerce, or daily life. At that point, the debate is no longer about whether something should exist, but how it should be managed. The window for prevention has closed, only mitigation remains. This sequence reinforces a sense of inevitability. Once a capability becomes real, opposing it can feel regressive or impractical. Even if ethical unease persists, society adapts not because consensus has been reached, but because adaptation is easier than reversal. The tension, then, is not between science and ethics, but between speed and deliberation. Scientific systems are optimized for discovery and iteration. Ethical systems are optimized for reflection and consensus. When these tempos diverge, capability sets the pace. This does not mean ethics becomes irrelevant. On the contrary, its role becomes more complex and more necessary. Ethical reasoning shifts from prevention to governance, from avoidance to responsibility. It must contend not with hypothetical risks, but with real, functioning systems that affect real lives. The recognition of this gap deepens the unease introduced earlier in the documentary. The silence after the discovery was not only about what had been achieved, but about the absence of a framework capable of fully responding to it. The realization that moral understanding would have to catch up to technical reality after the fact. And as ethics begins this work of catching up, another question quietly emerges. If capability continues to accelerate, will ethical reflection always remain one step behind? 7. The global consequence nobody announced. The transition from laboratory to world rarely feels dramatic. Scientific outcomes do not arrive with ceremonies or declarations of change. They migrate, slowly at first, then all at once, embedded within systems that already exist. By the time their presence becomes visible, they no longer appear new, they appear normal. What began as controlled experimentation did not remain confined to controlled spaces. Results were published, methods refined, tools standardized. What was once specialized knowledge became infrastructure. And infrastructure, by its nature, disappears into the background. It operates continuously, shaping behavior without requiring attention. This is how global consequences take form without global agreement. There is no single decision point where society collectively consents. Instead, adoption occurs through utility. Technologies that work are integrated. Systems that improve efficiency are scaled. Processes that reduce friction become defaults. Each step is practical, each adoption rational. No announcement feels necessary. As outcomes left laboratories, they entered institutions, healthcare systems, financial networks, communication platforms, supply chains. From there, they reached individuals not as choices but as conditions. People did not decide to live within these systems, they found themselves already inside them. Importantly, this spread was not coordinated by a central authority. It was emergent. Different regions adopted similar capabilities for different reasons: economic competitiveness, security, convenience, or innovation. The result was a shared global transformation without shared aid. Scientists as humans, not villains. At a distance, scientific progress is often spoken about as if it has intent, as though discoveries choose their own direction, or as though the people involved move forward without hesitation or doubt. This abstraction makes it easier to assign blame, but it obscures a more difficult truth. Behind every capability, every system, every irreversible threshold, there are individuals, humans working within constraints they did not design, navigating questions that have no clear answers. Most scientists do not experience their work as boundary breaking. They experience it as problem solving. Their days are filled with narrow questions, technical challenges, and incremental goals. The larger implications of their work often remain distant, not because they are ignored, but because they are hard to see from within the process itself. Doubt is more common than certainty. Researchers debate not only results, but relevance. They argue over interpretations, limitations, and unintended consequences. In private conversations, hesitation surfaces more frequently than confidence. The public image of relentless forward motion masks a reality filled with second-guessing and restraint. Many moments of scientific advancement are accompanied by quiet resistance from within. Experiments delayed, parameters narrowed, results withheld until they can be better understood. These decisions rarely make headlines, but they shape the trajectory of progress in subtle ways. Ethical concern does not always stop action, but it often slows it, redirects it, or forces reconsideration. What complicates these choices is the environment in which they are made. Scientists operate within institutions that reward productivity, publication, and innovation. Funding cycles impose timelines. Competition creates pressure. Collaboration spreads responsibility. In this context, choosing not to pursue a capability can feel like surrendering it to someone else who will. This creates a moral tension that is rarely acknowledged publicly. If something can be done, someone will eventually do it. The decision not to act does not eliminate the possibility, it merely transfers it. For many researchers, this reality reframes restraint as risk. By stepping back, they may lose the ability to influence how a capability is developed or applied. This is not indifference. It is pragmatism shaped by experience. Scientists understand that control is often greatest at the point of discovery, before systems scale and incentives multiply. Participation becomes a way to shape outcomes, even when those outcomes feel uncertain. Internal conflict is not a sign of failure, it is a constant companion. Scientists weigh curiosity against caution, potential benefit against unknown cost. They operate in spaces where clarity arrives late, if at all. The absence of definitive ethical guidance does not eliminate responsibility, it intensifies it. Importantly, very few scientists believe they are crossing lines in real time. The language of progress does not frame actions as transgressions. It frames them as advancements, optimizations, or solutions. The recognition that a line may have moved often arrives only in retrospect, when the cumulative effects become visible. This human perspective reframes the earlier silence. It was not the silence of conspiracy or concealment, but of recognition, a moment when individuals realized that the questions they were facing extended beyond their training, beyond their institutions, and beyond the tools available to them. By centering scientists as humans rather than symbols, the narrative shifts. The story is no longer about reckless ambition or moral failure. It becomes a story about responsibility under uncertainty and the limits of foresight in a system built for acceleration. This understanding deepens the documentary's core tension. If even the people closest to progress are unsure where the boundaries lie, who is left to decide when enough is enough? Intent. Public awareness lagged behind, because the changes did not demand attention. Daily life continued uninterrupted. Benefits were tangible, while costs were abstract or delayed. There was no visible crisis to trigger resistance. Adaptation felt easier than objection. This quiet integration altered how power operated. Influence shifted away from visible decision-makers toward systems that structured options before choices were made. Outcomes were shaped not by directives, but by design. The effect was subtle, but pervasive. What makes this moment historically significant is not that change occurred, but how it occurred. Without debate, without votes, without a unified narrative. The world adapted piecemeal, each part responding to local incentives, unaware of the cumulative transformation taking place. From a distance, this looks like inevitability. From within, it feels like progress. The absence of announcement does not imply secrecy. It reflects a deeper truth, that the mechanisms of change no longer require consensus to operate. By the time the global nature of the shift becomes apparent, it is already embedded across borders and cultures. Reversal is no longer a realistic option. Only adjustment remains. This is the consequence nobody announced. A world quietly reshaped by capability, operating smoothly enough that resistance never fully forms. And as everyday life absorbs these changes, the original questions about boundaries and responsibility fade into the background, replaced by new norms that feel as though they have always existed. 7. the global consequence nobody announced. The transition from laboratory to world rarely feels dramatic. Scientific outcomes do not arrive with ceremonies or declarations of change. They migrate, slowly at first, then all at once, embedded within systems that already exist. By the time their presence becomes visible, they no longer appear new, they appear normal. What began as controlled experimentation did not remain confined to controlled spaces. Results were published, methods refined, tools standardized. What was once specialized knowledge became infrastructure. And infrastructure, by its nature, disappears into the background. It operates continuously, shaping behavior without requiring attention. This is how global consequences take form without global agreement. There is no single decision point where society collectively consents. Instead, adoption occurs through utility. Technologies that work are integrated. Systems that improve efficiency are scaled. Processes that reduce friction become defaults. Each step is practical. Each adoption rational. No announcement feels necessary. As outcomes left laboratories, they entered institutions, healthcare systems, financial networks, communication platforms, supply chains. From there, they reached individuals not as choices but as conditions. People did not decide to live within these systems, they found themselves already inside them. Importantly, this spread was not coordinated by a central authority. It was emergent. Different regions adopted similar capabilities for different reasons: economic competitiveness, security, convenience, or innovation. The result was a shared global transformation without shared intent. Public awareness lagged behind, because the changes did not demand attention. Daily life continued uninterrupted. Benefits were tangible, while costs were abstract or delayed. There was no visible crisis to trigger resistance. Adaptation felt easier than objection. This quiet integration altered how power operated. Influence shifted away from visible decision makers toward systems that structured options before choices were made. Outcomes were shaped not by directives but by design. The effect was subtle but pervasive. What makes this moment historically significant is not that change occurred, but how it occurred. Without debate, without votes, without a unified narrative. The world adapted piecemeal, each part responding to local incentives, unaware of the cumulative transformation taking place. From a distance, this looks like inevitability. From within, it feels like progress. The absence of announcement does not imply secrecy. It reflects a deeper truth, that the mechanisms of change no longer require consensus to operate. By the time the global nature of the shift becomes apparent, it is already embedded across borders and cultures. Reversal is no longer a realistic option. Only the adjustment remains. This is the consequence nobody announced. A world quietly reshaped by capability, operating smoothly enough that resistance never fully forms. And as everyday life absorbs these changes, the original questions about boundaries and responsibility fade into the background, replaced by new norms that feel as though they have always existed. By the time the story reaches its final turn, something subtle but profound has already happened. The question is no longer what line was crossed, but why we believed a line ever existed at all. For generations, humanity imagined limits as if they were written into the structure of reality, immutable borders separating what could be done from what should never be done. These limits felt external, almost protective, as though nature itself would intervene if knowledge went too far. That belief created reassurance. It allowed progress to feel brave without feeling dangerous. But reassurance is not the same as truth. When examined honestly, the line was never a feature of the world. It was a psychological construct, a way for a developing civilization to organize fear, hope, and responsibility into something manageable. The boundary existed not because the universe enforced it, but because humanity needed it. It gave shape to uncertainty. It created the illusion that wisdom would arrive automatically at the moment it was needed. Yet modern science did not encounter that moment. It bypassed it. As capabilities multiplied, the notion of a fixed boundary began to lose coherence. Advances did not arrive as singular events demanding moral reckoning. They arrived as refinements, optimizations, iterations. Each step seemed reasonable in isolation, each decision defensible. The danger was never dramatic enough to force a collective pause. And so the line once imagined as a dramatic edge did not shatter. It dissolved through familiarity. What once felt forbidden became technical. What once felt risky became routine. What once required justification eventually required none at all. This is where the philosophical ground shifts beneath our feet. Without a clear boundary, progress no longer feels like a journey with milestones. It feels like motion without orientation. The question "should we?" quietly transforms into "can we do it better?" Ethics becomes reactive rather than foundational. Instead of shaping the future, it follows behind, trying to soften impacts already set in motion. Responsibility fragments across institutions, teams, algorithms, and timelines until no single actor feels fully accountable for outcomes that nonetheless reshape lives. And perhaps most unsettling of all is that nothing feels wrong in the moment this happens. There is no alarm, no rupture, no shared realization. The loss of the line does not announce itself as a crisis, it presents itself as progress. Comfort replaces caution. Efficiency replaces reflection. The absence of limits feels like freedom until it begins to feel like disorientation. What remains is not a warning about science itself, but a mirror held up to civilization. When boundaries disappear, direction must come from somewhere else, from values that are chosen rather than assumed, from restraint that is practiced rather than promised, from collective awareness rather than inherited myths. The line no longer exists not because humanity failed, but because it evolved faster than its stories about itself, and the unresolved question left hanging is not whether science will go too far, but whether a society without clear limits can learn to define purpose before capability defines it for them. By the time the story reaches its end, it becomes clear that there is no final revelation waiting to arrive, no decisive moment when humanity suddenly regains control or loses it completely. Science does not deliver conclusions, it creates conditions, and in those conditions, the most important variable is no longer technology, but awareness. The future did not emerge as an external force acting upon humanity. It unfolded from within human decisions, distributed across time, institutions, and incentives so diffuse that agency itself became difficult to locate. From a scientific perspective, this is not unusual. Complex systems rarely fail through singular events. They drift. Small feedback loops compound. Optimization in one domain quietly produces instability in another. In biology, evolution does not ask permission. It selects. In physics, systems follow gradients, not intentions. And increasingly, human-made systems behave the same way. Once a process is capable of self-improvement, self-scaling, or self-propagation, intent becomes secondary to momentum. Control shifts from conscious choice to structural inevitability. This is where the question no longer belongs to scientists alone, or policymakers or technologists. It becomes existential. If capability expands faster than comprehension, can meaningful choice still exist? If decisions are embedded in models, infrastructures, and automated processes, where does responsibility reside? Neuroscience tells us that awareness lags action. Sociology shows that systems outpace governance. Computer science demonstrates that optimization does not encode wisdom, only objectives. None of these disciplines offer closure. Together, they suggest a reality that is deeply uncomfortable. Humanity may still be choosing, but not always consciously, and not always collectively. The most unsettling possibility is not that science has removed limits, but that it has revealed something about us, that we were relying on imagined boundaries instead of deliberate restraint. The question, then, is not whether progress can be stopped. History suggests it cannot. The question is whether awareness can arrive before consequence becomes irreversible, whether reflection can scale as fast as capability, whether a civilization can learn to pause without being forced to. And this is where the documentary ends, not with prediction, not with warning, not with reassurance, but with uncertainty that refuses to resolve. If the future is already here, quietly integrated into everyday life, then the moment of choice is not tomorrow. It is ongoing. It is fragmented. It is happening now, in ways that feel too small to matter and too complex to fully grasp. The final question has no ending because it has no single answer. In a world where science can do almost anything, who or what is deciding what comes next?